Okay, this section is about 3.6 is about curve sketching. We did a little bit of this last year in pre-calculus, but we're going to do a different level. We've learned a bunch about graphs and their behaviors. We've taken the first derivative. We've looked see whether it's increasing or decreasing. And then we've taken the second derivative and looked whether it's concave up or concave down. We've used the second derivative test to tell whether we have a min or a max. We've used the first derivative test to tell whether we have a min or a max. We've done all sorts of things. All right, so now we're going to go ahead and take that and apply it to sketching some curves, some graphs. So we're going to sketch the graph of 2x squared minus 9 over x squared minus 4. I gave us a list of stuff that we need to find in order to help us graph these equations. Stay with me here because it's going to get messy. It's going to be long. And so when you're doing a problem like this, I would recommend clearing a big sheet of paper for this. And it's going to take up quite a bit of space. But anyway, our first thing on our list, try to stay with me here, is going to be the first derivative. So let's take the first derivative. We're going to sketch 2x squared minus 9 all over 2x squared minus 4. Let's take the first derivative. F prime of x equals, we'll have to do the quotient rules when we do this, right? So when we do the quotient rule, we bring up the bottom, x squared minus 4, times the derivative of the top. To clean up the top, 2x squared minus 18. Make it simpler for you, I don't know. So when we take the derivative of the top, we just have 4x minus, then we keep the top, so 2x squared minus 18. And we take that times the derivative of the bottom, which is just going to be 2x. That's all over the bottom squared. So x squared minus 4 squared. Okay, so let's clean up the top. When I distribute my 4x, I'll get 4x cubed minus 16x minus, in the brackets here, I'm going to have a 2x squared times 2x. I'm at 4x cubed minus 36x. And let's just go ahead and cancel out here. These are cross the line, change of sign. These cancel out. I'm going to have a 36x minus 16x. On my top, I'm going to have, so for my derivative, I'm going to write it over here so we can keep it. I'm going to have 20x all over x squared plus 4 squared. So there's my derivative of our function. And if my smartboard will cooperate, I would erase that. Okay, well, looks like it's not going to let me erase, which is okay. I'll remember what our derivatives was. So I'll erase that. Our first derivative was 20x all over x squared minus 4 squared. Well, we need to find the second derivative, which means we need to take the derivative of the derivative. So the derivative, we're going to have to do the quotient rule again. Bring up the top, x squared, or bring up the bottom, sorry, minus 4 squared times the derivative of the top, which times 20, minus, then you keep the top, 20x, times the derivative of the bottom. We have to do the chain rule on the bottom. So we're going to have to bring a 2 down, keep the middle, x squared minus 4, decrease my power by 1, so to x squared minus 4 to the first power, and then we have to take it times the derivative of the inside, so times 2x. And again, let's clean up the top. Well, no, we'll put the bottom in there. So then we're going to have x squared minus 4 squared squared, so it's going to be to the 4th power, because we have to square the bottom in the quotient rule. So let's clean this thing out. Clean this thing up. Looks like I'll leave my left side. I'll leave this side for right now. Let's clean up my right side. I'll have x squared minus 4 squared times 20. And when I multiply through everything, a 20x times 2 is 40x times 2x is an 80x squared. So I'll have minus 80x squared times x squared minus 4. All right. So if you notice throughout this entire thing, this top, I could take a 20 out, or a negative 20 really if we wanted to. I could take a negative 20 out, and I could take out also a x squared minus 4, because this term has an x squared minus 4 and this term has an x squared minus 4. So let's take out a 20, a negative 20. Let's take out a negative 20, and I'm left over with negative x squared minus 4 plus, when I take out a 20, I'm going to be left over with 4 x squared, and I'm taking out an x squared as well. Sorry, I forgot my x squared. So a negative 20 and an x squared minus 4 outside. I took out a negative 20 and an x squared minus 4. And that's all over my denominator, x squared minus 4 to the 4th power. If you notice, by taking out that x squared minus 4, I'm going to be able to cancel out right here. Sorry, I just cancel one of them, become a 3. Okay, so up top, I'm left over with negative 20 times a negative x squared plus 4 plus 4x squared. All right, and when I do that, when I add combine like terms, I'll have negative 20 to a 3x squared plus 4 all over my denominator, which is x squared minus 4 cubed now because we took one of the x squared minus 4's out. So that's how we took the second derivative. I'm going to erase this because I have it all written down on a piece of paper here. So my first derivative was 20x all over x squared minus 4 squared. And then my second derivative then was negative 20 times 3x squared plus 4 divided by x squared minus 4 cubed. All right, so there's my derivatives. Now the hard work's out. Taking the derivative, the hard work's out. X-intercepts. So to figure out what an x-intercept is, sorry, there's no rhyme or reason why I took my derivatives first. We could have figured out what the x and the y-intercepts were first. I just wanted to get the hard work out of the way. So to find an x-intercept, that means x-intercepts when x equals 0. That's an x-intercept. So we want to figure out what our x-intercept is. So we're going to plug 0 in for x and see what we get. So let's plug 0. We'll have 2 times 0 squared minus 9 all over 0 minus 4. So it looks like I'm going to have a negative 18 all over a negative 4, which is a positive 9 halves. So my x-intercept is going to be a positive 9 halves, which is 4.5, right? 1, 2, 3, 4.5. So my x-intercept is a positive 9 halves. My y-intercepts, all right, that's when y equals 0. So let's set the equation equal to 0. So 0 equals 2 times x squared minus 9. And to figure out when it equals 0, we don't want to know when the denominator equals 0. We want to know when the top equals 0. So our y-intercept is going to be where the top equals 0, because 0 over anything is 0. We cannot have 0 in the denominator. That's why we really don't care about the denominator. So we leave out our x squared minus 4. We just want to solve from the top equals 0. So when I divide by 2, I'm still left over with x squared minus 9. I'll add my 9 over. I'll get 9 equals x squared. And then I'll take the square root, and I get x equals plus or minus 3. All right, so my y-intercepts are going to be at positive 3 and negative 3. So look, I already have 3 points on my graph. All right. Vertical asymptotes. Vertical asymptotes occur when the denominator equals 0, if you remember from our pre-calculus days. When the denominator, because where it's undefined, we're going to have a vertical asymptote. So when is my denominator going to equal 0? So x squared minus 4, when does that equal 0? Well, it looks like a positive 2, because 2 squared minus 4 is 0. And a negative 2. Negative 2 squared minus 4 is also 0. So I'm going to have horizontal or vertical asymptotes at a positive 2 and a negative 2. All right. Next one, horizontal asymptotes. We just learned about that in the last section. All right. Limits at infinity. So remember what we do, we need to take the limit as x approaches infinity of our graph, which is 2x squared minus 18 all over x squared minus 4. Remember what we do, we plug infinity in first. Well, if I plug in infinity, I'm going to get infinity over infinity. All right, so then we have to discover, or we have to explore a little bit. Let's take everything divided by the lowest or the highest power in the denominator. So divide everything by x squared, x squared, x squared. When I do that, I'm left over with 2 minus 18 over x squared all over 1 minus 4 all over x squared. When I put infinity in there now, when I put infinity in for x here, we get 2 minus 0 all over 1 minus 0. Remember, that limit was 0. 18 over infinity is a really small number. It's really close to 0. So we call it when the limit's going to be 0. So My horizontal asymptote then is going to be at 2 over 1, which is 2. So I'm going to have a horizontal asymptote here. All right, critical numbers. Critical numbers when we set the derivative equal to 0. That's when it equals 0, and also it's going to make when our derivative is undefined. If you notice, our first derivative is this right here. Our first derivative is undefined at plus or minus 2. Well, we already figured out that negative 2 and 2 are horizontal asymptotes, so it can't be a minimum or maximum. All right, so plus or minus 2 would make it undefined. Also, then, when is it going to equal 0? So we set the top equals 0. So 20x equals 0, so x equals 0. We have a critical number at x equal to 0. And then the domain is going to be all real numbers except for plus or minus 2, right? Because it makes it undefined there. The last thing on my very bottom set the intervals we need to check. If you remember from pre-calculus, I just told you we needed to figure out what was going on inside of here. So from infinity to the horizontal, so on each side of the horizontal or vertical asymptotes, we need to figure out what's going on. All right. So we can do that, and we can do it using the second derivative test. All right. In the second derivative test, we can tell whether it's, or in the first derivative and the second derivative test, we can tell whether it's increasing or decreasing, and we can tell if it's concave up or concave down. So let's pick a point, -4. If I pick a point at -4 and plug it into our first derivative, I have -80 all over a positive number. So it's a negative number, all right, which means it's going to be concave, or it's going to be decreasing. So it's going to be decreasing. It can't be up here. It's got to go through -3. It's going to be decreasing, and it can't cross -2. And actually, if we plugged into our second derivative, it'd also be concave down. All right, I'm running out of time, so I'm kind of hurrying up a little bit. I apologize for that. All right, so now we need to figure out what's going on here. All right, we said we had a critical number was x equal to 0. X equal to 0, so if we plug 0 into our second derivative, we might be able to tell if it's a minimum or maximum, right? So if we plug 0 in there, I'll get 4 times a -20, which is a negative number all over a positive number. So my second derivative is a negative. All right, and a second derivative, I don't know, it shouldn't be. My second derivative is going to be a negative over a negative. All right, sorry. So I'll have a negative 80 when I plug 0 in, and I'll have a -4 cubed. So I have a negative over a negative, which is going to be a positive. Remember, in the second derivative test, if we get a positive number, it means we have a minimum. And it also, in the second derivative, tells us if we have a positive number, it's concave up. If it's concave up, it's got to hold water. So it has to come and approach these asymptotes here and look like a little parabola inside. And then again, on our opposite side of on the right side of +2, our vertical asymptote, we need to figure out what it's doing. So pick 4, all right? Plug it in the first derivative, see if it's increasing or decreasing. If I pick 4, I'll get 80 all over a positive. I have a positive over positive, so it should be increasing as x goes to infinity. So it'll be increasing. It's got to go through 3, so it just continues to increase, but it will never cross over a +2. All right. That was I had to hurry up at the end, but you just have to figure out what it's doing on each side of the asymptotes, whether it's increasing or it's decreasing. You can figure out whether it's concave up or concave down. All right, so my interval is what I tested. I went from -infinity to my horizontal asymptote, which was -2. Then I went from -2 to 0 because we had a critical point at 0. Then I went from 0 to 2, all right, just to tell that this was a minimum, all right. And then I went from 2 to +infinity to tell me what it was doing. So our knowledge of asymptotes, our knowledge of maxes and minimums, our knowledge of increasing or decreasing will all help us sketch these graphs. And just to prove to you that I'm right, I have graphed this on a graphing calculator, and that's what the graph looks like. So we are right. It has an asymptote at horizontal asymptote at 2, vertical asymptote at -2 and 2. Looks like it crosses the x-axis at 3 and 3, and this looks like 9/2 to me. So again, you might have to watch this video a couple times just to kind of, I had to go fast, just to kind of slow down step by step and make sure it makes sense to you. All right. So hopefully this helps, and we'll see you tomorrow in class.